Okay, so I'm gonna go over the weight and mass, the volume relationship. So I wanted you to watch the introduction video that I had found on YouTube, which is great. Now, this is an older edition of the textbook. So what I did is I put new textbook. You'll want to turn to page 19. And that's where our formulas are for weight, volume. So the first formula would be void ratio. So you'll see it as a little e. And that's the volume of the voids divided by the volume of solids. Now, this is what you call a block diagram. I had done this in AutoCAD, and typically I would hand it out and the students can use the formula sheet and this to work together. And when I work the first example 2.6 with you, I'll go ahead and work as much as I can by the block diagram, and then I'll plug in the formulas. So about the block diagram. So typically weights are what we can work with. So the total weight. So when you were in the lab, you went out and you scooped we went and got our dirt, brought it in, put it into the containers. In that container, you have solid soil. You've got some air in there, which are voids, and you've got some water that's inside those voids. So when you weigh it, that is the total weight. So before you scooped out some and put it inside your can, that's the total weight because it's got water, voids, and solid in there. So air weighs 0. So once we put it in the oven and we dry it, once it comes out of the oven, that'll be your weight of your solid. So anytime they give you a weight, that'll be everything combined together. If they say oven dried, that'll be your weight of your solid. So just kind of remember that. And then we can figure out what the weight of the water is because all three should equal the weight. So that's simple. You know, if you're given the two, you can solve for the other. Now, it's either dealing with, so the first example will work with weight and volume. So once you solve weight of the solid, then you can just look over here on the right side to get the volume that it occupies. That would be the weight of the solid divided by specific gravity of the solid times unit weight of water. So next week in the lab, you're going to be getting the specific gravity of both your soils. So we'll get into that a little more. So once we can solve the block diagram, then we can plug in the formulas. And they're really like a plug and chug. So the first one is the void ratio. And the void ratio is expressed by E. And so that's trying to give you a percentage of how much air that you have, or how much air and water that you have compared to the solid. That would be equation 2.7. The next one is porosities, and these simple equations can give us some much needed information that we're going to use in geotechnical engineering. So, we're going to start with a small one and we're going to work to complicated ones, so we're going to start off small. Porosity would be the next one, and that's shown as a little n. That's the VV. That's the volume of the voids divided by the volume. So on the right side, this is your volume. That's how much space it takes up. And then the volume of the voids, which is the air and the water, has to equal, the air and the water have to equal the volume of the voids, and then the two together will give you your total volume. So typically we could have a total volume if you know your specific gravity. We know how much volume that it contains. And like I said, we'll work our way up to that when we work problems. Then you have degree of saturation, which is the volume of water divided by the volume of voids times 100%. Now, I lined through these just so that they match up with your textbook, but this is identical to your textbook. Now, water content. The other day when we were in the lab, Wednesday, I was having you calculate the water content from your microwave oven. And what you would do is you would take the weight of the water. That was your initial weight. minus the weight that after you oven dried it, you found out how much water that was, divided by the, when you got to, some of y'all got to 37 minutes, and I was going to get and then times it by 100, that would give you your water content. And that water content can actually help you classify the soil. So I had a sheet that had typical values of moisture content, what, a sand was typically between 9 and 13, and a clay could be, anywhere between certain ranges. And that helps us classify it. So that's the first thing we did. And then unit weight, and unit weight is used, these are laboratory tests that we can then take out to the field and make sure that they're getting the right amount of density on that soil to be able to withstand the pressure. So you have wet unit weight and dry unit weight. And so the difference between just unit weight, that's your weight and volume. So in other words, that's with the water included in it. Dry unit weight would be the weight of the solid divided by the volume. So we'll kind of go with that. These are going to be the standard equations we're going to use. So 2.7 all the way through 2.14. So the next one would be unit mass. And that would be your mass divided by volume. So we'll work with mass later on. Right now we're going to be just working with weight and volume. But they're identical. So normally I just put them all on one and then we could line through if we're working with weights. Because weights is easier to weigh out into weights. You can weigh your soil in the lab and get a weight. So that's easier to do. And then the next thing you need to know is what the unit weight of water is. Because if we're trying to solve for volume of the solid, we have to know what the unit weight of water. If it is English units, we're going to be working with 62.4 pounds per cubic foot. And it depends on, for unit mass density of water, it's going to be 1,000 kilograms per meter cube. And if we're working with a weight in metric, that's going to be 9.81 kilonewtons per meter cubed. For kilonewtons per meter cubed. Alright, so let's kind of go ahead and let's jump right into one. So it says we're given the weight of the chunk of the moist soil weighed 45.6 pounds. So I'm going to go ahead and write that in over here, this on my block diagram. So I'm going to minimize this one for just to make this one bigger so I can write on it. Alright, so since I know that we're working with just a weight, I'm going to line through this. So it's given us a weight of 45.6. I'm going to leave the pounds off just so I can write in here. And then after it was oven dried, it was 37.6. And then given was the volume. So I'm going to write volume here, 0.4 cubic foot. So those are the 3 things that are given in the problem, and it gives you the specific gravity of the solid. So I'm going to just write it down here, GS. And that's 2.65. Alright, so if this is English units, you would normally typically want to keep these to 2 decimal places. So right now while I'm looking at this diagram, I can tell if I know what the weight is, and I know what the weight of the solid is, I can determine by the weight of the water. Because weight of the air and the weight of the water and the weight of the solid has to equal W. So I'm just going to come down here and I'm going to kind of write that in. So the weight of the air, which is nothing, plus the weight of the water, plus the weight of the solid, has to be W. And so W is what you initially weigh out before you put it in the oven. So if this is 0, we want to find the water. After we oven dried, it was 37.8. I'm going to go ahead and put my pounds in here now because I got room to write. And then 45.6 pounds. So once I solve for WW, that'll be 45.6 pounds minus the 37.8 pounds. WW would be 7.8 pounds. Alright, so what I'm going to do is I'm just going to write that in up here. So where we just solved that, that is 7.8. Alright, so before I even go to solve the problem that they're wanting, they're going to want certain formulas. They're going to want us to solve for water content, unit weight of the moist soil, void ratio, porosity, and degree of saturation. But I need to get these values based off this block diagram. So once you're given the weight of the solid, you can just jump down here and solve for the volume of the solids. So because the weight of the solid is 37.6 pounds, we can then divide it by the specific gravity, which is 2.65, times unit weight of water. So I'm just going to go ahead and scroll down and do that formula. So volume of the solid is the weight of the solid divided by specific gravity, so that's called SG, times the unit weight of water. So volume of solid, so we just solved for that. It's 37.8 pounds divided by specific gravity, which is 2.65, times unit weight of water. So this is in pounds. Specific gravity is it doesn't have units. This is 62.4 pounds per cubic foot. So our pounds will cancel and we'll be left with cubic feet. So you should get volume of solid 0.23. cubic feet. So I'm going to go back up to my block diagram and go ahead and put that in there. So I'm going to write it right here so I can see it. That'll be 0.23 cubic feet. Alright, so if they give you the original volume being 0.4, and we know that the volume of the void and the volume of the solid has to equal V, we can just say 0.4 minus the 0.23. So that gives me the volume of the void. So this should be 0.17. Alright, so volume of the water is the weight of the water divided by unit weight of water. So the weight of the water is the 7.8 pounds. So I'm going to come down here and put that formula in next. So again, volume of the voids, I'm just going to write that because we know it's 0.17. And then the volume of the water equal to the weight of the water divided by unit weight of water, which would be 7.8 pounds divided by 62.4 pounds per cubic foot. And it'll leave us with 7.8 divided by 62.4 will be, and I'm going to go ahead and round it up, 1.3 cubic feet. Alright, so I'm going to go ahead and scroll back up and plug that in. So that's 0.13 feet cubed. So what's left over is the air. So if the volume of the voids, that's the water and the air, are a total of 0.13 or 17, and the water is 0.14, then what's left over is 0.04 cubic feet. So now we have everything solved. We have a VA, volume of the air, 0.04. We have the volume of the water, 0.13. We have the volume of voids, which is just these two added together. And then we have the volume of the solid, which we solved by using the weight of the solid times specific gravity. So now I can go ahead and plug in what they're asking for. All right, so the first thing required is water content. So water content. So water content is equation 210. So I'm going to write equation 210. And water content is the weight of the water divided by the weight of the solid times 100%. And the weight of the water we found out to be 7.8 pounds divided by the weight of the solid, 37.8 pounds, times 100%. So if you solve for that, you should get 20.6%. So if I wanted you to actually put that, if I say keep it to 2 decimal places, most of the time I'm getting, I got 20.63. So let me I'm going to go ahead and put it all the way in. That would be 20.63%. Alright, so that's the first thing that we wanted. Second thing they want is unit weight of the moist soil. And unit weight of moist soil will be equation 211, which is going to be, looks like this. That's a unit weight. W over V. So our W is our total weight, which is the 45.6 that was given, pounds, divided by the volume, which was given, 0.4 cubic feet. Excuse me. Alright, so when the next one would be 45.6 divided by 0.4. That'll give you 114 pounds per cubic foot. So I'm going to go ahead and get me another page or two because I only have 3 other things to solve for. Alright, third thing they want is void ratio. So void ratio is the little e. And I know when we start doing this and we're putting it in, all the numbers will kind of seem like they overlap. So that should be equation, I'm going to write equation 27, which is E equals volume of voids divided by volume of solids. This is not multiplied by 100, so sometimes people will do that. It is not. So our volume of voids were 0.71 divided by the volume of the solid, which is 0. I did this a minute ago. Changed my number. Got it backwards. So that's actually 0.17 divided by the volume of solids, volume of solids, 0.23. So if I did the 0.17 divided by 0.23, that'll give you 0.74. So that's our void ratio. Fourth thing they asked for is porosity. So they want to know what porosity is. Porosity is that little n. And that would be equation 28. So that'll be the volume of the voids divided by the volume times 100. So our volume of voids is 0.17 divided by V, which was given. These are both cubic feet, so the cubic feet will cancel, times 100 to put it in a percentage. So if I say 0.17 divided by 0.4 times 100, that gives me 42.5%. And the last thing they want is degree of saturation, which is S equals, and this one's equation 29, volume of water divided by volume of voids times 100. So our volume of water was 0.13 divided by the volume of void, 0.17 times 100. And that gives me 76.47%. Alright, so I'm going to look and compare it to the answers in the book. They have 76.5. So as you see, if we keep it to 2 decimal places and I have you put it in, it'll work out pretty good. Alright, so I'm going to save this one and stop it and load the video for you into Blackboard.